Hello everyone. Welcome to a new video of wide player programming. And you may notice that it has been a long time since I've uploaded another video because I've been busy lately. And I'm going to announce a few changes before the tutorial starts. So I'm going to speak English for the rest of the C++ tutorial. First, as a challenge to myself. Second, so that more people can benefit from this tutorial. Okay then. Let's dive into today's topic. Today's video is the part 2 of pointer. It will be about array and pointer arithmetic. First, let's discuss array. An array allocates contiguous blocks of memories. You can see the first line of the sample code indicates the declaration of the array. This statement allocates an array named ARR with the size of 3 integers. Note that the index of array starts from 0. Therefore, the 3 integers indexes are 0, 1, and 2. As mentioned earlier, the memory allocated by declaring an array is contiguous. The graph in the slide is an example how an array might be allocated. If we want to access the memory allocated by the array we declared, we can access it by index. You can see in the slide, ARR with square brackets 0 can assign the value of it to 3, and the corresponding memory block with that address will hold a value of 3 as a result. Let's see some example. Okay, let's now see what we can do with array in C++. Let's first declare an array called ARR, and we want it with a length of 3. Now, if we want to initialize it, there's several ways to do it. We can do it by using a bracket containing the element you want, or we can use a for loop to get access to the element inside of the array and just initialize the value with assignment. So this for loop will assign array from 0 to 2. And if we want to get access to the data stored in array, we can always use for loop and indexing to see out or manipulate with the data inside an array. So let's see out. Okay, let's compile this program and see the output of this executable. First, you need to compile the program using pointer2.cpp. This should give us a .out here, and we can execute it. We successfully print all the value we assigned here, and we print it out right here. Let's get back to the slide. Next, we are going to discuss pointer arithmetic. Let's review the slide of the array because pointer arithmetic is highly correlated to array. If you still remember the tutorial in part 1, then you should be able to read the code in this slide. Int var declare a variable named var with value of 5, and int star ptr holds the address of var, which is also shown in the graph. So the address of the variable ptr is 1000, and it's holding the value of var's address, which is 1008. Now, because ptr is a int pointer, so when we dereference it with a star sign, it will indicate the value 5. Here, ptr plus 1 will result in value of 1012, which means that pointer plus 1 is the pointer to whatever is stored in 1012. Some might ask, what happens then if we dereference this pointer? Well, the answer is whatever that is stored in 1012 now. But the thing is, it is definitely not controlled by you. And most of the time, you won't want this event to happen in your program. After you are familiar with array and pointer, let's make a comparison between them. As you can see, int ARR bracket 3 is the declaration of an array, and ARR bracket 0 give you access to the value stored in ARR. Let's see the right side of the slide. The first statement, int star ptr, indicates an integer pointer. If we want to use this pointer to access an address of an array, there are two ways we can use ptr to access the memory of ARR. First, we can access the address of the first element in the array. It is the same as accessing a variable address. Second, you can just directly assign an array's name to pointer. The syntax will be more complicated if we try to use ptr to access the value of an array. Note that the ptr is now pointing to the address of the first element of ARR, which has index 0. So dereferencing the pointer is equivalent to left-hand side ARR square bracket 0. What if you want to access the second element of the array? The second element of an array has an index of 1. So we dereference the ptr plus 1 to get the second element in the array. And note that this expression is equivalent to the left-hand side ARR square bracket 1. Let's see example to understand more clearly. Let's take a look at another example. So this is the code we used in the last example. We are going to keep this, the array and assignment, but we are gonna do another thing. So we declare a pointer to an integer, and we want this pointer to point to the first element of an array. And now I am gonna demonstrate that you can do exactly the same thing with pointer. If you recall, in the previous example, we assigned value to an array, cout value of an array by indexing with the array name. But what I am going to demonstrate is that with pointer, we can achieve the same thing we just did. This access the value inside an array is exactly the same with ptr plus I. Given that this pointer points to the first element of the array, and the pointer calculates its value according to the type it points to. So in this example, it points to an integer. So ptr plus I is going to be equivalent to the address plus 4 bytes times I, which is the same to ARR square bracket I. Let's see for ourselves if this is true. Here we assign the value with the pointer, but we cout the value with array. Let's compile and let's execute. And note that it's still the same. How about we change a little bit? How about we switch the way we get access to the value in the array? Let's put it here, and let's move the pointer assignment here. And it's going to give you the same result. Here's the tricky part. You don't actually have to use this symbol to get the address of the first element of an array. You can actually just assign the array name directly to the pointer. So let's see if this is really true, that we can assign a name of an array to a pointer. Alright, we can actually do that. The cout is correct. So what happened here? So this name, when it's assigned to the pointer, it decays to a pointer. So as you can see with the previous terminal log, the program still executes perfectly. So remember, an array name can be assigned to a pointer. Let's get back to our slides. After the introduction of the array and the pointer arithmetic, there's still one thing I want to talk about. Is array name a pointer? We can see in the previous slide and examples, an array name can be assigned to a pointer. But does assigning an array name to a pointer necessarily mean it's equivalent to a pointer? Well, if you want the short version, it's almost the same. Most of the time, if you consider the array name as a pointer, it won't trouble you too much. The long answer is an array name actually decays to a pointer. An array name actually possesses more attributes than a pointer. Then what's the difference? Well, the main difference is that there's a built-in function in C++, sizeOf, and this sizeOf works on types, and it only works on array name for array. So today, if you use sizeOf on integer pointer, it will not see the size of the array the pointer is pointing to. But if you use sizeOf on an array name, it will be able to see that it is an array and the total allocated memory size. Let's see example for more information. Okay, now let's take a look at example 3. This is the previous code I used in example 2. The main point of this example is trying to explain that an array name is not a pointer. The C++ built-in function sizeOf can identify the size of an array, but it cannot identify the size of an array the pointer is pointing to. How come? Okay, let's see. Let me see out the size of an array. And this line is going to work perfectly. It's gonna see out 12. Whereas this line see out the size of a pointer is going to be 8 in this case. First, let's compile and let's execute. What this sizeOf function does is that it actually returns the size of the pointer. It does not return the size of the array it's pointing to. So the difference between an array name and a pointer is that the array has more information, more attributes. And that's it for today. I will keep on making programming videos, especially in C++. If you really like my tutorial, please don't forget to hit that subscribe button. I will be really grateful.